Algebra 2.1. Welcome to another exciting video. Sort of. The nonlinear systems. That's today. We're going to wrap up our systems week, and this is the last lesson, just like the last melon on Ice Age. Okay, the last lesson that we're going to be doing for Unit 1. Your test is this week. Get ready. Okay, I'm going to be going through a lot of questions tomorrow on the video for the review, for the Unit 1 review, but still, you ought to be preparing on the review as much as possible. Okay? Bell work, homework quiz, and then nonlinear systems, that order. Awesome. This is the only one I have because I have 3 questions on the homework quiz. So I only want to go through this one because this lesson can get really lengthy and I don't want to take any more time. So first of all, look back at your 3x3 systems. Let's see what kind of, is this a whole graph? Is this a whole equation? Like, is there holes in here? Well, yeah, we can see that there's a hole right here, right? Is there a bonus at all that I can eliminate using this? Not really. So it looks like this is going to be a straight hole equation. Okay, this is going to be a straight hole equation. So what does that mean? All right, first steps first. We're going to choose two equations, and then try to eliminate one variable. Okay, so I'm thinking right here. Okay, if this is equation 1, this is 2, and this is 3. So I can eliminate z, right? That seems easy enough. So let's do 2 and 3. Awesome. So 2 and 3. So my second one is x and then plus y minus z equals 6. This is going to be 2x plus 2y plus z equals 0. This is actually amazing. Okay, this is 3x and then plus 3y equals 6. Fantastic. Okay, now, yeah, we can use 1 right here. So let's use 1 right there and just plug it right in. Wow, this one's going to town. Look at this. So now we can actually solve this linear system. This is great. Okay, so does it matter which one? It doesn't seem like it matters. Let's multiply this one by a negative. So the x's go poofy, and then I'm left with 2y equals 0. And so that means y equals 0. So we got y. Awesome. So now let's go to 1. Let's plug in the first equation. Let's plug 0 in for y. So equals 6. And then, so that means I have 3x equals 6. And so x equals 2. Wow, this one's going to town, guys. And now let's do the second one because it's the easiest one right here with all the x, y, and z. It's only a negative z. So x is 2, y is 0, negative z equals 6. Wow, this one's great. This one's so fast. Okay, so that means I'm going to subtract the 2 over, so negative z equals 4. So z equals negative 4. Perfect. What's my final answer? Final. 2. And then 0 and negative 4. Perfect. My little unicorn. Sweet. Great. That's how you do it. 3x3s. That's with a hole. In the little graph right here, there's something that's blank, so that's a hole right there. That's technically 0 times z, Oz. Okay? So that's a really simple example right there, but hey, still works out. Make sure you get that down and get started on the homework quiz. 3 questions, 30 minutes. Open notes, of course. Okay, try your very, very best. A lot of these can probably get on partial credit, so if you need partial credit, just email me, let me know, blah, blah, blah. Okay, and then begin your corner notes for nonlinear systems. What are nonlinear systems? Well, they're nonlinear, and they're systems, okay? They are systems of equations that are not linear. That's really what it means. We've done 2x2 linear systems, 3x3 linear systems, but what if we have nonlinear systems? What if we have 2 equations, but some of them are quadratics? What do I do then? Okay, quadratics and systems of equations, we can still solve it. So This is going to be kind of hard because we're going to be using some review from Algebra 1 with your quadratics. I'm going to kind of sprinkle that in a little bit, okay? So I hope that's all right. We are going to do a vast review of quadratics in like a month or so, but this is going to be kind of a precursor to that. I hope you remember a lot of your factoring techniques, a lot of your radicals, because we're going to be doing some radicals. So we are going to be reviewing all of this throughout this quarter, but this is going to be a nice little preview. Okay. So what's systems review? So really, this is a 2x2. We can solve this 2x2. Hey, we can solve it on Desmos. This is a 3x3. We cannot solve it on Desmos. We can only solve it algebraically by hand. But what if we had to solve for x and y if one of the equations, what do we do? If one of the equations is nonlinear. Okay, so literally meaning a not a linear equation. So if we have something like this, what do I do? What do I do? Well, first of all, there's this helpful tool called substitution. So you can still solve it like you normally would a 2x2. And the first thing that we do is substitution. So here are the substitution steps again. I'm just going to put them up on there because the substitution steps are amazing. Okay, I love substitution. And we're going to see how substitution even works in these examples. So I'm only going to go through probably 3 substitution, probably 2 elimination, 2 of choice, and then 1 application. So we have a lot of math to get to. This is going to be a really like pummeling video. All right. I hope I can explain it adequately enough. All right. Let's get started. We're going to go through this one. These are probably really challenging. So if you like a challenge in math, if you're like, ooh, wow, this is easy, this is a nice challenge, you're welcome. Okay, how do I do this substitution? Well, first of all, guys, I see y equals. Y equals this. Sorry, y equals this. X squared minus 6x plus 8. Now, do not factor this. I don't think it, well, yeah, it can be factored. It can be factored, sure, but it doesn't really matter. Okay, it's not going to solve anything. Like this being factored doesn't do anything for you. Okay, if I factored this right here, all that tells me is where this graph is going to cross the x-axis. It doesn't tell me where it crosses the other graph. So what we're trying to solve is literally where they intersect. These graphs intersect. That's what I want to try to solve. And the cool part about it is that it will intersect in one particular point. Okay, but it will more than likely intersect in 2 points because this is a line and then this is a quadratic. So this will actually intersect in 2 points. So instead of solving just 1 point with 2x2 and 3x3s, this is actually going to intersect in 2 points. I will also, after solving it algebraically, I'll show you how to do this on Desmos. Okay, the vast majority of these problems can be solved using Desmos. But none of that. Let's get to it. This is y equals this junk right here. What is that junk? Well, it's y equals. So I can literally substitute that in right there. So I have x plus, and then everything in red is literally substituting, not y. Is literally me substituting it in for this y. Okay? That's what I'm doing. So minus 6x and then plus 8. And then we finish out the equation equals 2. Okay? So now when I start simplifying this, I can combine some stuff. So this is x squared. This is negative 5x. And I'm actually going to transfer this 2 over to become positive 6 equals 0. Now, what you see here is something that you can factor. This is something that we should remember how to do in Algebra 1 because it was the major thing in Algebra 1. So pay very close attention. If you don't remember anything from Algebra 1, this is you that I'm talking to. How can I have factors of 6 that somehow, some way add up or subtract to my negative 5 here? I'll say it again. What we're trying to find are factors of 6, things that multiply to get to 6. That's what factor means. When I say factor, it means things that multiply to get to 6. What are 2 numbers, when multiplied, give me 6, but at the same time, those 2 numbers also add or subtract to negative 5. That's what we're asking. What 2 numbers multiply to get to 6, but at the same time, add or subtract to -5. It should be very obvious. There's not a lot of numbers that multiply to get to 6. The easiest ones, 2 and 3. 2 plus 3 is 5, right? Yeah, okay. But the problem is this is a -5. So what needs to be on the 2 and 3? Negatives. So what does this look like? If you guys remember, our basic template looks something like this, where x goes here and x goes here. This is what we're calling factoring, kind of working backwards from FOIL, okay? Working backwards from FOIL. So what goes in these spaces? It has to be a -3 and then a -2. Now, why is that? Because a -3 minus 2 gives me a -5, but a -3 times a -2 gives me a +6. Okay, so if I foiled this out, first x squared, next -2x, -3x, and then 6, the -2x and the -3x will combine into -5x, but when they multiply, they give me x6, and then x times x is x squared. So if I foil this out, first, outer, inner, last, what I get is literally the exact same thing. So what we did was we're working backwards. I hope you remember that, okay? Or at least something along those lines, okay? If not, then you need to come talk to me pronto. We need to talk after our class meeting, and so we can do some of this stuff, okay? So now what does this mean for us? This literally means I take each one of these and set them equal to 0. Okay, that's called the zero product property, which means x equals 3 and then x equals 2. So I have 2 x's. Now, are those my answers? No, those are half your answers. This is technically my first step. My second step is I'm not following these steps exactly. I'm following them very, very loosely. Okay, I'll say that. I'm following them very, very loosely. These are just to remind you that this is how we do substitution. So, second step, what would I technically do after that? Okay, well, I take each one. I take each x and I plug it in. Now, which one is probably the easiest to plug it in? Probably the first one, okay? Because it's just x plus y. So let's do that. So x, my 3, okay, plus y equals 2. So that means y equals -1. Okay, so this is my first y. Now, right after this, pay very close attention. You ready? Right after I find my y, I'm going to write down my point. I had 3 for my input, -1 for my output. This is my answer. Okay, that's my answer. 3, -1. Okay, right after I do that, so I don't get confused about where I'm plugging stuff in and blah 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 blah. So now, what about my other substitution, my other x, 2? So let's do that. So I have 2 plus y equals 2, and this one's easy. So y is just 0. So what does that mean? What is that point? That point is now I plugged in 2 and I got out 0. So that is my point. Oh, I didn't cloud it. Oh, shoot. Okay, well, maybe I'll just box it. Oh, that looks like junk. Okay, well, these are my two answers. Those are my two answers. 3, -1, and 2, 0. What does that mean? That means that you have a parabola crosses your linear function right here. It crosses that parabola in 2 spots, 2 points. Remember, when we solve a system, we're trying to solve for the intersections. What does that look like graphically? Let's find out, kids. So that's my answer. Let's look at what it looks like graphically. Okay, so let's erase all this. This is from the previous video. Okay, so first things first, let's write it down. What do I have? I have x and then plus y equals 2. And then my next equation, I had y equals x squared. And then I had -6x and then plus 8. Awesome. So you see what I have here. Let's zoom up just a tad bit. This is my parabola in red. This is my parabola. That's my parabola. And this is my line. Now, when we put them on the same graph, where do they cross? Is that not what we found right here in green? 3, -1, 2, 0. 3, -1, 2, 0. So, do you really even need to solve it using algebra? No, okay, you don't. Okay, the first thing I would honestly do if I was taking a quiz or test on this, and if I'm allowed to use Desmos, the first thing I would do when I see a problem just like this is not solve it algebraically. I mean, maybe I would, but more than likely I would not. What I would do is plug it into Desmos. Okay, I'm almost commanding you to use Desmos. I'm almost commanding you to use Desmos. Now, you don't have to, obviously, right? I don't really care what you do. Okay, use Desmos or graph it or algebraically solve it. I know some of you will probably want to algebraically solve it. That's fine, but you can save a ton of time just plugging into Desmos, and then boom, there's your answers. Both of them. Both of them are your answers, not just one, but both. Remember, it's where they cross. That is your answer. If it crosses the graph, if they intersect in more than one solution, or more than one place, there is another answer. I need to stress that. You know why? Because I've been doing this a long time, kids. And whenever I get to Math Excel, they'll always have, inevitably, your homework quizzes will always have one of these, but then you'll just forget the other one. Like, you'll just have this, and you won't even select that. I'm like, what? You don't clearly understand intersections then in systems. We have a system because it crosses there. Crosses. Right? So those are your two answers. I want to emphasize that. And so now when we move on, we don't need to go over that. Okay, so let's erase this. Let's just start going to town on these, okay? So this is elimination. I'm always going to solve these by hand, and I'm only going to do a select few on Desmos, okay? So elimination, the first thing I want to do is straight up, not elimination, my bad, substitution. So the first thing I want to do is just substitute one of these. This is y equals. Well, hey, that's a y. So all I have to do is just, boop, just put it right there. So what does this equal? This is my first step, negative x squared plus 6x plus 9, and then equals the rest of the equation, x squared plus 2x plus 3. Okay, this is how you find an intersection, okay, an intersection point. So what will this look like? Well, we need to combine like terms, of course, and we also need to make sure everything's on one side of the equation. So I'm probably going to move everything over to the right, to the left. So I'm going to move everything over to the left. If I minus x squared here, that means I have negative 2x squared because it combines right with that. If I move the that's 2x, so minus 2x, that will become positive 4x. And then if I move that over, that will be 9 minus 3, which is 6, equals 0. Yeah, I know I did that fast, but we should know how to combine like terms by now. That's how I see it. So just minus everything over and combine like terms, all right? Everything can be divisible by negative 1. I don't want that negative there, so I want to divide everything by negative 1. I also want to divide everything by 2. So that means I want to divide everything by a negative 2. So what I do to one side, I have to do to here. That goes poofy. I'm left with x squared negative 2x and then minus 3 equals 0. I can do that in math. So what is this? Now I can actually factor this beast. This is my basic template. Okay. Now, what are factors of negative 3 that somehow, some way add or subtract up to negative 2? There's literally only two factors of 3, 3 and 1. So can I somehow, some way add and subtract 3 and 1 together to get negative 2? Well, yeah. Which one needs to be negative? The 3 needs to be negative, and then the 1 needs to be positive because negative 3 plus 1 gives me negative 2, but negative 3 times 1 gives me negative 3. What does this mean? X equals 3, and then x equals negative 1. Remember, and I'm not going to do this every single time. I don't want to do it every single time. Remember, this is x minus 3 equals 0, and this is x plus 1 equals 0. Okay, and then we just solve for x. Literally subtract over. Okay? Seriously, that's all you need. Subtract the 1 over, and then you get negative 1. That's it. Okay? That's how I get that. That was my first step. My second step, now that I have 2 points, I need to plug them into my y. Does it matter which one? No. Let's do the first. So I have y equals, let's do 3. So this is going to be 3 squared, and then plus 2 times 3, and then plus 3. This equals 9, and then plus 6, and then plus 3. This equals 15, and then plus 3, which equals 18. Okay, what does that mean for me? That means my y is 18. What does that mean for a point? That means 3 comma 18 is one of my answers. Okay, now let's do the other one here. So -1. So y equals, let's plug it into the same equation, -1 squared plus 2 times -1 plus 3. Okay, this is just going to be 1. Anything squared is a positive. Minus 2 plus 3. This is -1 plus 3, and this equals 2. What does that mean for us? What does that mean as a point? That means I plugged in -1. I got out 2. This is my second answer. Could you plug that into Desmos and get the same thing? Absolutely. Okay, absolutely could have. But I didn't. I solved it completely by algebra because I'm awesome. So let's erase. Let's go through one more substitution. And this substitution is going to be kind of gnarly. Okay, this one for kicks and giggles. Okay, this substitution is more like an honors question. If you're not in honors or don't need to do honors or not doing honors, feel free not to look at this question because this one's kind of interesting. The reason why this is interesting is because it's multiplied here. Okay, how do I solve it? There's a couple ways to solve it, especially using substitution. And so I think what I would do is a couple things. I solved it differently on my paper here, but I think I want to kind of solve it. Let's try to solve it this way. So let's get x by itself. So x equals 12 all over y, okay? Which means I need to then substitute that in for that. So let's do that. Okay, so that means I have 2 times 12 all over y, and then I have minus y equals -2. Okay, so this becomes 24 all over y minus y equals -2. I want to combine terms here, so I need a times y times y. So that actually gives me 24 minus y squared all over y, and then equals 2. But then I need to get rid of this y, so times y, that goes poofy. Let's finish it over here. So now what do I have? I have 24 minus y squared equals 2y. Now this is good news because now I can just combine everything and factor, right? So let's combine everything, move it over here. So 0 equals, so I have y squared and then plus 2y minus 24. I can factor this out to be y minus factors of -24. Somehow, some way add up to 2. So 6 and 4. So that means plus 6 and then y minus 4. And so that means y equals -6 and positive 4. Boom. Awesome. So that's my y's. So now let's plug them into my first equation to get my x's. So this is x timesing my first y here, -6 equals 12. I divide by -6, so x equals -2. So what's my first point? My first point is this, -2 and then -6. Okay, and now let's do my other one. So x times 4 equals 12. So then x equals 3. And then my actual point is 3, and then what's 4? So that one wasn't too difficult. I don't think it was too difficult. The hardest part of that question was trying to figure out how to substitute. So I guess it worked out. There's a lot of different ways to do this. It's not like if I changed this to be 2x minus y equals -2, and then -y equals -2x minus 2, and then y equals 2x plus 2. And I plugged it in there. So if I did x times 2x plus 2 equals 12, this would be 2x squared plus 2 equals 12. And then you would just solve it like that. Divide each one by 2. And then you would have to do that. But that doesn't seem like it's getting the actual answer. So I don't know. I don't need to solve it that way. But I encourage you, maybe, because you guys are students, right? So do it that way. See if you can get the same answers, okay? Or plug it into Desmos, double check it, and then see if you can get the same answers. But I don't need to solve it that way, and I'm not going to finish it that way. So I don't know how else to solve it, but that's one route that I would probably take. I would probably take that route, minus, and just plug it in, and then that would be 2x squared, and then oh, that's plus 2x. That's my problem. This would be plus 2x. That's it. Plus 2x minus the 12 over divide by, yeah, and then you'll get the same thing. Got it. All right, so let's erase. Now let's go through elimination. These steps are just to remind you what elimination is. I'm not going to follow these steps. I'm going to follow them very loosely. So how do I eliminate this? Well, there's a couple things on how to eliminate this. I think the first thing I would probably look at is, I don't know, I'm trying to think. I guess the y squareds. So I guess you could do the y squared. So let's multiply this one by 4 and then this one by 3. So my first equation is 16x squared and then plus 12y squared minus 19 equals 0. And then I have 15x squared and then minus 12y squared. And then, whoops, I didn't do that, minus 76. Sorry. This is minus 76. And then my other one is 48, but let me get there. So minus 76. And then 3 times negative 16 is negative 48 equals 0. I can add these. So now that goes poofy. And so now what I have is 31x squared. And then these together, negative 76 and negative 48, is minus 124 equals 0. And so this is becoming negative 31x squared equals 124 divided by 31. Does this work out? Holy junk, it does. Okay, so this is x squared, still x squared, equals 4. Now, what happens here? I hope you guys remember. How do I get rid of a squared? I have to square root. It's the inverse. So that goes poofy. And so now what I'm left with is just x equals 2. But not just 2, plus or minus 2. Okay, there's a plus or minus 2 here. Why? Negative 2 times negative 2 gives me 4, positive 4, which is what I have. But also, positive 2 times positive 2 gives me 4. So I need to include both. Okay, so these are my x's. How do I get my y's? Well, I just plug them in. And so let's give me 1 second. So yeah, let's plug in positive 2 first. Let's do that. Let's do this equation. Okay, let's plug in positive 2 first. If I plug in positive 2, I get 4 times positive 2 squared plus 3 y squared minus 19 equals 0. Okay, so this becomes 4 times 4 is 16 because 2 squared is 4, so 4 times 4 is 16. This becomes plus 3y squared minus 19 equals 0. This becomes 3y squared, negative 3 equals 0, so 3y squared equals 3, y squared equals 1, and then y equals plus or minus 1. So this is interesting. Now watch. So I have plus or minus 1 because I square root, right? Now watch this. Ready? I had positive 2. So I plugged in a positive 2. I got out a positive 1. But I also plugged in 2 and I got out not just a positive 1, but a negative 1. So I actually got 2 points with 1 dice. Okay? So you need to pay very close attention to how I'm doing these problems, especially this. So now let's go and solve for the other one. And I'm guessing we're going to get 2 equations again. So let's plug in negative 2. Okay? If we plug in negative 2, will it really change? Think about it. If I plug in negative 2, let's actually change this. If I plug in negative 2 here, guys, negative 2, will anything change? Literally, will anything change? If I plug in negative 2 squared is still 4. 4 times 4 is still 16. Does anything change at all? No. I will literally, if I plugged in 4 times negative 2 squared plus blah, 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 I still get that, which means I plug in a negative 2 for x, I get another positive 1. I plug in a negative 2 for x, and I get not just positive 1, but minus 1, which means these are my final answers. I know, it kind of seems like ridiculous, right? I'm going to plug this into Desmos, and we're going to see how many we actually get. So let's do that. Okay, so make sure you have this written down. Let's go to Desmos. Turn these off. Let's plug this stuff in. Ready? So I got 4x squared. Okay, 4x squared, and then plus 3y squared. And then I have minus 19. Okay, and then equals 0. Nice, kind of like an oval. All right, and now I have 5x squared, and then I have minus 4y squared. Wow, I want that. Okay, and then minus 16 equals 0. Oh, okay, so this is awesome. You know why? Because in pre-calculus, this is technically like awesome. This is what we call an ellipse, and this is what we call a hyperbola. Okay, look at where they intersect. So they intersect at the same points that we thought. So now, if you have this question on a homework, okay, because you will, can you just literally plug it into Desmos and just pull out those points? Again, I will say yes. You don't need to do all this math. Okay, I show you the algebra because I want to, and I think it's fun, but this right here is really just what you need to do. You just need to plug into Desmos exactly how you see it, and then you will get where the points intersect. Now, why don't I choose this point, the decimal? Because that's not the point you're interested in. You're interested in where they intersect, where the graphs actually cross each other. That's where you're interested in. Okay, I'm going to jump around here because I don't want to do all these examples. So I'm going to erase this. I'm not going to do this one because this one's actually rather difficult, but I challenge you. I challenge you to do this one if you really want to get to it. I'll give you the answers. Okay, so this is 0, 7. This is 0, negative 7. And this is negative 2, and then 4 radical 2. And then this is negative 2, and then negative 4 times radical 2. And if you're like, how can you actually solve that? You can. Okay, you can, I promise you. But for the sake of time, I'm just not going to go through it. Okay, you can do it yourself if you want. I know some of the honors kids will probably want to try to do that. But I challenge you, do it. See if you can get it. Okay? But I'm going to skip that one. I'm also going to skip this next one here. I'll give you the answers, though. And I just want to get to, I'll probably skip the next two. So the answers for this one is 4, 3, negative 4, 3, and then negative 1, 0. So again, I challenge you, try to get that. Now, of course, this is a straight Desmos question. The last question is not a Desmos question. Okay, the last question is not a Desmos question because it has a radical, and Desmos doesn't give you radicals. Oopsie. Okay, so this question right here is a straight Desmos question. Very simple. You can plug it in. Awesome. And then you'll get the 3 points. Same thing here. This is going to be another Desmos question. And so it's really, really nice. For the sake of time, because I don't want these videos to be long, I'll probably do the last one on Desmos just straight up. Okay, so right here, the method of your choice, it is a Desmos question. I'm actually going to plug this in. I am going to say that this is Desmos. And I will show you what the answers are. And then I'll show you how to do it on Desmos. So negative 4, 9. And then I have negative 3 halves. And then 1/4. Now, Desmos does give you a decimal with these points. However, because these are simple fractions, like very simple fractions, they can be put into Desmos as decimals, and then you can get a fraction back out. These are actually very, very simple, okay? So if you don't want to do any of the legwork, then do this. I'm going to show you right now. Go to Desmos.com and plug these in. So let's do it. Let's erase these. Let's plug that in. So I have y equals, and then in parentheses, I have x plus 1, and then quantity squared, so a parabola that shifts 1 to the left. And then I have 7x plus 2y, and then equals negative 10. So I have that. So now, a lot of funky stuff here. Oh shoot, I have 7y. 7x, sorry, 7x. Still some funky stuff, so let me zoom out. So it will cross in one point right here and one point right here. Now watch. These are the points where it crosses, okay? These are the points where it crosses. One right here, -4, 9, and right here. That's a decimal. Now, just because it looks like this does not mean you can't plug it into Desmos and try to get a fraction out of it. This is one of your points. Easy. That's -4 and 9. That's what we have. Now, these are fractions, but how can I get these decimals into fractions? Well, -1.5. I can type in -1.5, and then I can toggle this fraction button to give me that value. And that's exactly what I did. And it's that simple, guys. 0.25. Now, if you do not know what 0.25 is, that is just, I don't know what to say to you. Okay, it's a quarter. It's 1/4 of a dollar. 1/4. Okay, 0.25 is 25%, and there's 4 times 25 is 100%. So those are my actual points, -3/2 and 1/4, and that's exactly what I have here. So even with Desmos, when you get decimals like this, you can still try to kind of toggle this fraction button here, but you need to try it out, okay, is what I'm saying. Okay, now let's erase this and let's get to my last example, an actual word problem. I'm not going to solve it by hand for the sake of time, but I will kind of plug in Desmos. A planet follows an elliptical path described by 16x squared plus 4y squared equals 64. A comet follows a parabolic path, y equals x squared minus 4. Where might the comet intersect the orbiting planet? Okay, where might the comet intersect the orbiting planet? And so what we can do is plug these two equations in to Desmos, and then we will get an answer. We'll get all the answers that we need. Okay, let's do it. So I'm going to plug them in. My first one was this, 16x squared. And then I had plus 4y squared and equals 64. That's an ellipse. And then right here, what I have is y equals x squared and then minus 4. Perfect. So this is your little comment. I'll do it in yellow. So it's traveling, okay, and where might the comet intersect? Okay, well, it can intersect here, it can also intersect there. So where are those points? Where can I see where they intersect at? Zoom up. So right here and right there. That's it. -2, 0, 2, 0. That's my answers. Right there. Boom. Done. I need the full points. -2, 0, 2, 0. I need both. Okay? So that's where the comet might intersect the orbiting planet. Sweet. So we used a lot of stuff today. We used a lot of Desmos. We learned a lot of nonlinear systems stuff with substitution. We even reviewed some algebra 1 here. So we recognize systems of nonlinear equations with two variables if they have a squared on them and stuff like that. Solve nonlinear systems by substitution, addition. We also looked at solving problems such as word problems with nonlinear equations. Okay, so I want you to have a great day. Make good choices. Make sure you do the homework quiz. We do have a homework quiz on nonlinear systems, okay? It's just going to be 3 questions again, 30 minutes, same thing as the 3x3. So I hope the 3x3s weren't too terrible for you, but nonlinear systems will be 3 questions, 30 minutes. And again, you can use Desmos on these, right? You can use Desmos. You can actually type in and get the points and where they cross. Absolutely. Okay? Without further ado, this is C squared mathematics, guys. Peace out.